Hi everyone, I'm going to go ahead and go over the answers from the review that you had trouble with. I'm going in order from least to greatest, so if you don't need to see them all, you can skip around. Just watch for the number on my screen. So the first problem that you asked to see was 13. 13 tells us a couple of different things. It wants us to solve for theta, so that means solve for the angle that has a sine of square root of 3 over 2. So that has a y value of square root of 3 over 2. And it also tells us something very important right here. It tells us it has to be between 0 and 2 pi, which means that it has to be in radians. If it was between 0 and 360, you would give your answer in degrees, but because it says 0 and 2 pi, you give your answer in radians. So we just go to our unit circle, we look for where the y value is square root of 3 over 2, and we know our two answers are pi over 3 and 2 pi over 3. So most of the time for these, you'll have two answers. Just use your unit circle and look for the two answers. So that's all for number 13. So number 16 is what we did on Tuesday in class, the last thing we did before I left. And it's got a couple of things here. It also tells us that this answer has to be in radians. But it gives it to us in secant. I don't like secant because we don't have anything on the calculator to help us with secant. So instead we're going to rewrite this as a cosine problem. And I know the cosine is the reciprocal of secant. So if I know secant, I just flip it to get cosine. And then I use my calculator. Let's go ahead and do this in degrees for just a second. Now this would not get me full credit because it wants radians. I'm just doing this to help with the explanation. So we do the inverse cosine of 1 over 1.192. And we just go to our calculator. If we're doing it in degrees, we make sure it's in degrees. And so then you type it in, you do the inverse cosine of 1 divided by 1.192. Close that off, hit enter, and we get 32.97 degrees. So we know that the theta, let's try this, theta equals 32.97 degrees. But remember, there's two places where cosine's positive. All students take classes. So the calculator's only given us this one that's in the all category. So it's only given us that angle. We also need this other angle that's down here. So because this is cosine, to find the other angle, I'm going to do 360 minus. So 360 minus 32.97. And that would give me, I don't have a calculator right in front of me. Let's say 360 minus 32.97, which is 327.03 degrees. Now, of course, that's degrees. That's not what it was asking for at all. But remember how I told you, I think degrees are easier. So radians, we would do the exact same thing. We would do the inverse cosine of 1.192. We go to our circle, we do mode, enter, and I'm going to type the exact same thing in. Maybe I'm going to type the exact same thing in. There we go. And you get the radians equals 0.5754. 0.5754. So theta equals 0.5754. So that's the one answer, but remember it's also in the other quadrant, so you have to do 2 pi minus that. So if you use your calculator and do that, you get approximately 5.7. So your second angle is 5.7. So those are your two answers, and those are the two I would expect to see. Now you absolutely do not have to do this one. The degrees are just there to kind of help you visualize it. You only need the radian answers. Alright, moving on to this question, 17 and 18. So it says, what is the height in inches above the floor of the tip of the second hand 20 seconds after it passes the 12 on the clock? So if you think about 20 seconds is really where the floor is located, and that's a 30-degree angle from there. So we have a 30-degree angle, and it tells us the diameter of the clock is 16 inches, so that means the radius is 8. So we have 8 there. And I need a height. So if I'm looking for that, I know the sine of 30 equals opposite over hypotenuse. So it's 8 times the sine of 30. So y is 4. So this has a height of 4. And if we look at this, we know that radius is 8, right? So 8 minus 4 is 4. So that gives us this distance right here, 4, plus the 60 inches to the floor. So it's 60 plus 4, which is 64 inches. And I'm wondering now if my answer key for that one was right or not. I think it was, but I can't remember exactly. So that's how you would do that one. Now, let's look at 18 for just a second, then I'll talk for a minute about this question. It says, what is the height in inches above the floor at the 50-second mark? So we know 50 seconds is where the 10 is on the clock. And lo and behold, that's also a 30-degree angle. So it's going to be the exact same y value of 4. And we know it's 60 inches to the bottom of the clock, 8 inches to the middle, and 4 inches up. So it will be 72 inches. Once again, I don't remember if my answer key was right or not for that one, but it should be 72 inches. Now, remember when you did the clock project yesterday, you got a bunch of decimal answers. And on your test, there's going to be some multiple choice answers that aren't decimals. They're going to give you weird answers, like maybe 60 plus the square root of 8. Well, if you have a decimal answer, then just change all of their multiple choices to decimals. So if they give you 60 plus the square root of 8, just type in 60 plus the square root of 8 and see if your decimal answer matches that. So once again, you're going to probably get a decimal because that's how we've been solving these. And they're going to have a bunch of answers like this. And just change all of these to decimals and see which answer matches your decimal. It seems like that would be common sense, but it hasn't always been, so I wanted to just mention that. Alright, so now let's talk about reference angles. So the first thing I would do for this reference angle is I don't really have a clue where negative 560 degrees is located, so I would add 360 degrees. And negative 580 plus 360. So negative 580 plus 360 gives me negative 220. And I would probably go ahead and add that one more time. Go ahead and add 360 one more time. So that gives me 140 degrees. So I know 140 degrees is over here in this quadrant. And I know my reference angle would go up from 180, so that would be a 40-degree reference angle. Remember, reference angles always come off of the x-axis and you measure the angle measure up. 110 degrees likewise would also be in that quadrant. So 110 degrees, you measure the reference angle up. So for measuring up from 180, it would be 180 minus 110, which gives us 70 degrees. So that reference angle should be 70 degrees. Now, negative 11 pi over 3. And that one's another one. I'm not really sure where that is on the unit circle. So let's add 2 pi, which is really adding 6 pi over 3. And if I add 6 pi over 3, that gives me negative 5 pi over 3. And that's not really enough, so I'm going to add 6 pi over 3 again. And lo and behold, I get 1 pi over 3. Well, 1 pi over 3 is an acute angle, right? It's only 60 degrees. So that is my reference angle, pi over 3. So 5 pi over 6, we know that's over here in this quadrant, because you have 6 pi over 6. This would be 3 pi over 6. So you know 6 pi over 6, 5 pi over 6 is just a little bit less than 6 pi over 6. So if you subtract them, 6 pi over 6 minus 5 pi over 6 is 1 pi over 6. And that's all there is to the reference angles. Alright, so then 39 says using the given point on the terminal side, find the value of the trigonometric function indicated. So really this wants secant, so I don't, you know me, I don't really care for secant all that much. I'm going to start by finding the cosine. So I have this lovely angle right here. If I just draw a quick right triangle here, I know that let me redraw it actually. I know that my x value is 6, and my y value is the square root of 13. So if I need my hypotenuse, I go 6 squared plus the square root of 13 squared equals c squared, or 36 plus 13 equals c squared, or 49 equals c squared. So c would equal plus or minus 7. And we know that the hypotenuse is always a positive number, so the hypotenuse is 7. And we know the cosine is x over the hypotenuse, or the adjacent over the hypotenuse. So the secant will just be that flip, so 7 over 6. And this is in quadrant 1, so everything's positive in quadrant 1. So if we do the same thing over here with this one, we have our right triangle. We know our x value is 6 and our y value is negative 4. And we solve again, so 6 squared plus negative 4 squared equals c squared. So 36 plus 16 equals c squared. So 36 plus 16 would be 52. 52 equals c squared. And if I take the square root of both sides, c would equal plus or minus the square root of 52. But I believe 4 goes into 52. Yeah, 4 goes into 52 13 times. So this is really 2 square roots of 13. And it's the hypotenuse. The hypotenuse is always positive. The y value is negative, but the hypotenuse is positive. And this one's the cosine. So cosine is adjacent over hypotenuse. So 6 over 2 square roots of 13. And 6 divided by 2 would be 3. So it's 3 over the square root of 13, which is 3 root 13 over 13. And I believe that's all of your questions. It is. So good luck studying tonight. If you have anything else, you can send me a remind message. Fortunately, I'm doing okay, so I should be able to answer your remind messages. All right. Good luck.